We a little behind time, but that's not your fault, right? So what we want to do today is we want to complete the Jan 2025 paper 2, right? Now, if anybody doesn't have their paper with them, let me know. I'll print out the questions as we go along. But let me know. What's that? Okay. Right. So yeah. So let me know if anybody needs a copy of the questions we're going to be right. Okay. So 8AB. Sorry. Really? Okay. I give me 1 sec. Yeah. Raise it like increase the temperature. All right. Cool. All right. Let me see. Still. Okay. Right. That go it. All right. So who needs a printer of the question we're doing currently? 2. All right. Cool. Want me to do one for you? No. Okay. All right. Cool. Right. Oh, here's Julie. All right. Hey, evening, Juliana. How you doing? Good to have you on. Evening, Donovan. How are you?
Good day, sir.
All right. Good to have you on. All right, folks. So, because I want to finish questions 8, 9, and 10, and usually 9 and 10 are very involved, circle geometry, trigs with bearings, then matrices and vectors, right? We're moving with a bit of pace today. So, I'm going to give you guys a few minutes to work out whatever's on the screen. Again, you're not under exam conditions currently. We are in revision. If anything you see on the screen or on the paper, you don't know how to do, you can't remember, you're very free to ask, right? So, let's start. I'll give you a few minutes to work out what's on the screen here. All right, those online, if you can't see what's there, let me know. I'll see if I can send you pictures in the chat. Question 8. All right, so I'll give you a couple minutes, right? So those on Google Meet, right? So of course, don't forget you can send me pictures of your work as you go along. All right, so Donovan and Julie just popped in. Not seeing Janaya, Josiah, Nyla. So the R's. All right. Good evening to those on TikTok. I see Faye, KSIC, ASM. Because the abbreviations today, boy. All right. Oh, thanks for sharing live. I appreciate it. Thank you very much. And thanks for the follow. That's amazing. All right, Jadon. Hey yo, yeah man. Your crash course is in April, but I had to get back to you with the dates because I'm watching when the term ends. The term ends I think on the 11th, and then Easter's on the 18th. So I had to see, right? So most likely that period crash course will probably start. It might even start earlier that week, like the 7th or something. Oh yeah. Yeah, man, Jada. You could always reach out to me on Instagram, TikTok, WhatsApp, email. Because I think 2 or 3 people have signed up for it already. But I had to set my dates, I had to set my plan. I'll just sorry, repurpose my plan from last year. But yeah, if you want to book your spot early, you don't have to pay in the booking spot. Yeah, you'll only pay when you crash course starts. Sorry. Hey guys, sorry about the cough. I don't know. I've been fighting out something since last week. It's Alina, Aquarius, what vibes? What is it? Answer is 4. Alright, that sounds good to me. Oop. Oh, that's the smallest, okay. Is there a split screen on this boy? Page color, page size, new window. I wonder if I could do that boy. Alright, let me see. So new window. Boom. Alright. This one. at a resize and all kind of thing. Oh crap. Alright, well yeah, that would make sense. Here's Aisha. Alright. Right. Hey, evening Aisha, how you doing? Yeah, don't worry, we have started too long. Right, so this is the same paper, Jan 2025, paper 2, this is question 8, part A. So we're dealing with the functions part of it first. Right? So in a couple of minutes, I'm going to go through it on the screen right now.
Sure. Okay. So whenever you found out, probably 1 plus 15 plus minus 3x over 5 minus x minus 1. And then it's going to reduce 16 minus 3x.
Cool.
So I think you want me to go through that again. Okay, cool. And then for this last part, you're finding the inverse. So what I'm going to do is we know that x is equal to 1 plus 3x
Hey, Tori,
over x minus 1. So we also know that f of x is another way of writing y. Right? So what I'm going to do first is I'm going to substitute y where f of x is. So that's going to give me y is equal to 1 plus 3x over x. So that's my first thing. We want to find the inverse. So you know how there's like sine and sine inverse. So this is kind of the same thing. So the first thing I'm going to do is I'm going to interchange my x and y. So I'm going to turn into x is equal to 1 plus 3y over y minus 1. And then I'm going to solve for y. So I'm going to multiply my both sides by my denominator, y minus 1. So that's going to turn into x by y minus 1 is equal to 1 plus 3y. So just transpose this to other.
So it's done 2 pages.
Okay. So we got up to switch it. Alright, so nice. Okay. So I want to get rid of this denominator. So we normally have like a regular fraction, like let's say 5 over 3. If we want to move, or let's say x over 3. And we want to get rid of the 3, we multiply both sides by 3. So instead of it being 3, I'm going to multiply both sides by the denominator. So if I do multiply both sides by y minus 1, this cancels all this, leaving us with this on this side. Is that right? So this is what I'm left with. I'm gonna
Sorry.
expand my brackets, and then I'm gonna bring my y terms to one side, and then my constants to the other. So how that's gonna look is x by y is xy. X sky minus 1 is minus 1. Minus x is equal to 1 plus 3. Okay, I'm gonna bring my y's to this side, and I'm gonna bring my x to this side. So this x, to bring it across, I'm gonna add x to both sides. And then to bring this 3y across, I'm gonna add x to 3y to both sides.
But if it is this given trouble, you can go ahead and go ahead
So that's gonna give me xy minus 1 is equal to 1 plus 2x. Is that okay? So I still have to, the reason why I'm writing down is I'm gonna plug out the y now.
Alright.
You'll see, if it helps, when it comes to like finding the inverses for like
Cheeto Weedo.
stuff
No
like
vibes.
this,
I feel like I saw your name before. It's a very memorable name.
So this is okay. I'm gonna punch out my y. Y into xy is gonna give me back x. Y into minus 2y is gonna give me minus 2. I'll go over it again, don't worry. So that I factored it out. The last thing I'm gonna do is I'm gonna divide both sides by my brackets to make y.
Sorry.
So y is gonna be equal
You guys, sir, body cough.
plus x.
I really wish it would just
x
disappear.
minus 3. Okay. And then I could just like re-replace it. So f over t equals. Do you want me to go through that again?
Well, let me take a start now, and I'll go through it on the screen, right?
Oh, okay.
Yeah.
But no kind of seeing visual and all the loss.
Yeah. That's all right.
In it. So you equal f of x to y, switch your x and y's, and then make y subject to the formula again.
Well, we'll get to that one. Don't worry. We can come back and regroup. All right. But yeah, but that's why we're here. All right, folks. So let's go through this first part with functions. So the functions f and g are defined as follows. So f of x. All right. Hold on. Let me see. Right. F of x is this kind of fraction looking thing. 1 plus 3x over x minus 1. So we call these types of functions. So come on, man, Philip, if yourself. Yeah. Let me zoom out a little bit so I could have an end. I'm gonna have to copy and paste these things next time. All right, cool. Right. So we call this type of function a rational function. Now, the reason we call it a rational function is because it's basically a fraction. There's a numerator and there's a denominator. So we call it a rational function because it's the ratio of the numerator to the denominator, right? Any fraction is also a rational number. All right? Let's switch in. Oh, okay. All right. Now, this interesting little piece here. What is this item in the circle here saying? X is not equal to 1. Can anybody tell me why, for this function, x cannot be equal to 1? Correct. If you substitute x equal to 1 into your fraction, into your function, right? Specifically your denominator. What's 1 minus 1? 0. Now, if you have a fraction and your denominator is 0, what's the understood operation between numerator and denominator in any fraction? Divide. But if your denominator is 0, let's just put 1 over 0. Can we divide by 0? No, we can't. It's actually called or referred to as being undefined. So that's why they have this thing here. As a matter of fact, what they do sometimes is they'll give you a rational function. They'll give you a function as a fraction. Sorry, I didn't mean to erase that. Right? Yeah, they'll give you a rational function and they'll ask you for what value of x is the function undefined. Or they'll ask you what value of x cannot exist in the domain for f of x. Oh, everything right? Okay. Right. So to answer that question, if they give you a rational function and ask you, hey, what value of x would make this undefined? It's whatever value makes your denominator equal to 0. Right? Or if they ask you what value of x cannot be in the domain of f of x or g of x, whatever the name of the function is, it's whatever value gives the value, makes the denominator equal to 0. That can't exist, right? Okay, now, with functions, you're basically just substituting for the simple ones, right? So like here, if they want f of minus 2, all we have to do is substitute minus 2 into the function, right? So for example, let me use my space, right? So we have to find f of minus 2, right? So we have 1 plus 3x. So we're going to substitute our minus 2 there first. And then in the denominator, we have minus 2 minus 1, right? Because we're replacing each x with the value in the bracket, right? Which is minus 2. So like I said, for a lot of functions, it's simply substitution, right? Oh, you all right? Oh, okay. Okay, so what's 3 by minus 2? Minus 6. So you have 1 plus minus 6. And in your denominator, minus 2 minus 1. So when you have two negatives like that, what do? We add, we add them together and put back the minus sign, right? If you were multiplying or dividing two negative terms, yes, you get back a positive term, right? But when you have, think about it on a number line. If you have 0 here, and you have minus 2, and you have to minus 1. So when you're minus 1, you go in one space to the left. So that way, that's why the answer will be minus 3. Right, so we have minus 3. And now in the numerator, 1 plus minus 6 basically simplifies to 1 minus 6. So here, same thing. If you have 1 and you're minus 6, you're going 1, 2, 3, 4, 5, 6 spaces to the left. That's minus 1, minus 2, minus 3, minus 4, and minus 5. So we're going to end up with minus 5 over minus 3. And this is where what you said comes into play. Between the numerator and the denominator, what's the understood operation? Division. And when you divide a negative by a negative, you get back a plus. So you could put it back as 5 over 3. There's no need to put a plus sign. It's understood. If you put it, it's not wrong. So you don't have to worry about that. Okay? Okay. Now, it says in the next piece of the question, determine, a simplified expression for fg of x. Well, this is called a composite function, or some people say a composition function. What it means is you actually are substituting one function into another, right? So when they want f of g of x, right? G of x is this expression here in the yellow, right? So what they want you to do is they want you to actually substitute the entire expression 5 minus x into the first function. So anywhere there's an x in the first function, you're going to substitute the entire expression for g, which is 5 minus x. All right, so to find f g of x, so some people like to write it like this. So they're going to find f of the entire function g of x. So you have a 1 plus 3 by x, and over x, then minus 1. All right, so what is our expression for g? G is 5 minus x. All right, sorry. Okay, I'm going to scroll down a little bit so I can get a little more room to write. Okay, so in this first piece, in the numerator, we have to apply distributive law between the 3 and the bracket, right? What's the understood operation between the 3 and the bracket? Multiplication. So we have to multiply the 3 by each term on the inside. So 3 by 5 will give us, and 3 by minus x will give us, minus 3x. In your denominator, we have no distributive law to apply. We just have to drop the bracket. So 5 minus x minus 1. Okay. So in the numerator, what could simplify? 1 plus 15 will give us 16. So we have 16 plus 3x. And in the denominator, hold on, give me 1 sec. I forgot to plug in my cooler. Right. So you have 5 minus x minus 1. So what could simplify? 5 minus 1. What's 5 minus 1? 4. So you have 4 minus x. Right? So you can leave it like that. Some people like to put the algebra first, but it does not matter. They both mean the same thing. Right? Either one of those is perfectly fine. Okay, I'm going to zoom out a little bit. Yeah. Right, and I'm going to send this in the chat. So my Google Meet people, right? So Google Meet. So Aisha, Christian, Donovan, Juliana, and Jaquan. If you guys are good with what I have on your screen, give me a G in the chat. If you need me to re-explain, please give me an R and tell me which specific part you want me to re-explain. All right? 1, 2, 3, 4, 5. Okay, that's everybody. All right, cool. All right, and in class people. All right. So Zia and D'Angelo, you guys okay with what I show on the screen there? All right. Paige, Ziri, how about y'all? You cool with that? Leo? Are you finished your whole thing? Or you could have told me I could have sent the solution? As if you told me I would have sent you the solution.
No, I only had like one more question.
Was that the vectors?
No, I skipped out the
Uh-huh. I don't know.
one of the geometry questions.
Circle geometry?
Yeah.
Oh, interesting. All right. Mishka's used. Just go and take a peep and see which one she's talking about that you skip out now. Thanks. All right. Eco-minded supplies. Sweet ice candy. How you looking? All right. Oh, is anybody here not in the group chat? Right. Julie, you in the group chat, right? You in the group chat, right? All right. Honey, if you're in the group chat, I added you last week, right? And Noah and Jaden did a long time, right? Okay, great. All right. Folks, say what? In the interest of time, what I want to do is I want to go down. I send the picture in the chat already so you can pull it up there, right? But I want to go through the inverse one. Sorry. Wouldn't it be minus 3x? Yes. It would be minus 3x. Thank you very much. Look at that, eh? Sorry, minus 3x plus 16. And then you could even do a little fanciness here and divide everything by minus 1. And we could actually get 3x minus 16 over x minus... Whoops! What the hell happened there? Yes, thank you. You just have a symbol for your name, so I don't know what to call you, but thank you very much. You are very correct. Right? And you see why going over your work is also an important thing to do? All right? Yeah. And it's so interesting that I did it in the denominator, right? But for the numerator, for some reason, I did not. You know. All right. Okay, cool. All right, so maybe I should delete that picture and send the fresh one. Sorry, what? Because I had an error in it. So I send it back now with the correct item. Right. Yes, so again, thank you, blue symbol person. Do not know what to call you. I don't know what symbol is. Is it Wi-Fi symbol? Blue diamond. Blue diamond. Right, cool. Okay, going down now. So derive an expression in terms of x for the inverse function f inverse x. All right. So the inverse of what you might call it, rational functions is always a little bit of a challenge for some people, and that's okay, right? We, as Ms. Rachel says, you can do hard things, right? So the convention is you have to let the function equal to y, or let y equal to the function. Whichever way you do it does not matter, right? So y is equal to, what was it again? One plus 3x. Oh, I don't know how I get out of there, but all right. All over x minus 1. Sorry. Okay, so the first step you could do is you can literally just swap out x and y. All right. Now, what an inverse function does is it undoes whatever was done to x, right? But long story short, you are transposing it. So after you switch out x and y, you want to make y the subject again. All right? Okay, so first things first I would do here is whenever you have a rational function, usually you want to clear out the denominator. How is the denominator connected to the numerator? What operation? Don't be shy now. What operation is understood between the numerator and the denominator? Division. So if I wanted to remove, quote unquote, remove my denominator, I would use what operation? The opposite, which is multiplication. So the first thing I'll do is I'll multiply by the denominator. So it's going to look like this. X by y minus 1. Right. Now here, when I have x and then y minus 1 in the bracket, what's the understood operation between the x and the y minus 1? Multiplication. So I'm going to use my distributive law to expand. X by y will give me xy, and x by minus 1 is just going to give me minus x. Right? Now that's equal to 1 plus 3y. Now remember, I'm trying to make y the subject of the formula. So what I want to do is I want to bring all the y's on one side of the equation and all the non-y's on the next side. Okay, well, it seems to still be going. Right, so what I'm going to do, let's bring across the 3y on that side and carry across the x on that side. Now, the 3y on the right side, what operation is between it and the 1? Addition. So to remove something attached by addition, what I would use? I'd use subtraction. So I'd subtract 3y from both sides. And here, I'm subtracting the x. So when I want to, quote-unquote, move it across, I need to use what operation? Addition. So I'll add x to both sides. Right. Okay, cool. Right, so now I want to make y the subject, but I have two y terms. So the trick we could use here is factorization. So when we factor, you pull out the y and you divide each term by y. xy divided by y is x. Minus 3y divided by y is minus 3. Right? And what we could do, we could swap out here. Well, just, yeah, swap positions. And now, you want to make y the subject. It's connected to a bracket, x minus 3. But what operation is understood there? Multiplication. And to remove something attached by multiplication, we use division. So we're going to divide by the bracket. So when we divide by the bracket, it basically goes across to the next side and becomes the denominator. And that there is your answers. And the last thing you have to do is literally state that as the answer. So you state, therefore, f inverse x is equal to x plus 1 over x minus 3. All right? And if you notice, it's worth 3 marks. So you have a few steps well, and that's how you, sorry, how you earn your marks. Oops, careful, careful. Yeah, so they only 2 acceleration portions there.
So perfect.
And clearly, yeah, m, yeah. Is that conference? Is that conference? Oh, you going what? Oh, okay. Okay. For moral support. I don't know. Is that a whole? Oh. Yeah, no, but he was clearly sleepy today. I know if fighting or something. Right. Okay, Google Meet. If you guys are good with the multicolor thing on the screen, let me know. Give me a quick G in the chat. If you need me to re-explain any or everything, let me know. It's not a problem. Alright, okay. I should have done that one. Cool. Sorry. Alright, so as you can see, basically what we did, we just kind of transpose. We swap out x and y, we made y the subject of the formula, and just call it x inverse. Oh, sorry, f inverse, my bad. Right? And that's basically to kind of undo anything that was done to an x term. All right. I want to show you real quick what we mean by the inverse function, right? When I say I showed you how to get it, right? But what I mean is what is it doing? What does an inverse function actually do? The word inverse means opposite, and another word you could apply to it is undo. What form is this? Form 5. Form 4/form 5. Right? So check this, right? What I want you all to do, I want you all very simply to find f of 2. Right? Now, I know the first question was f of minus 2, so no, I want you to find f of 2. So sub 2 inside of here. No, just sub 2 into the original f function, right? Daniela Walcott, as in one of my students from like back in the mid-2000s, and who also went there for Miss Trinidad. All right, for those who just join us, I'm trying to show you what an inverse function does. So I want you to find f of 2. So you're substituting 2 instead of that original function, right? Right. So what's 3 by 2? 3 by 2 is 6. What's 1 plus 6? And what's 2 minus 1 in the denominator? 1. And 7 over 1 is just what? 7. Right. What an inverse function does is it literally undoes the function and gives us back the original value. So if I were to find f inverse of 7, you'd plug 7 inside of here. So I want you to plug 7 inside of that green function. Right? You plug in 7 inside the inverse function, and you should get back the original value of 2 for x. Right? So you're substituting 7 inside of here. The inverse undoes what was done to the value, right, to get back the original value. So we plug 2 inside of here and we got 7. So if you plug 7 into the inverse function, it will undo what was done to that and give you back 2. Right? So the value. Right. So in the first question, if you plug that back into the inverse function, you'll get back -2. You should, if you do your calculations correctly. Right? So check it. If we put 7 plus 1 over 7 minus 3, what's 7 plus 1? 8. What's 7 minus 3? 4. And 8 divided by 4 is 2. And wasn't that the function that we plugged into f in the first place to give us 7? Right. So that's what an inverse function does. It takes the output and puts it in the inverse and undoes what was done to it to give us back the original x value. Right? So that's what an inverse function does. Okay. All right. So folks are going to take a picture of this and send it in the chat. Then we're going to go on to the distance speed time graph question. Sorry. Oh. Rather cough than a sore throat, yes? All right, so folks, I'm gonna switch up now. So if you're still copying it down, you can always look back in the chat. Okay, so I'm gonna put this up on the screen. We're gonna take a read first. So the velocity time graph below describes the journey of a car over a period of 70 seconds. The journey is represented in 5 stages labeled 1 to 5. So those are Roman numerals. I don't think they teach them anymore. I don't know. Back in the day, we used to be taught them. But, they still do? Okay, well, that's cool. Yeah. All right, cool. So on the horizontal axis, you have time, and you'll note it goes from 0 to 70, because the question did say is it the journey of a car over a period of 70 seconds, right? On the vertical axis, you have velocity. Now, sometimes we refer to velocity as speed. Now, they are not the same, but for the purpose of CSEC maths, you could consider them interchangeable, right? Velocity is actually something called a vector quantity. It has both magnitude and direction. Whereas with speed, you only have magnitude, you have no direction, right? Now, you'll notice that the vertical axis, of course, goes from 0 to 50, but the values don't go all the way up, but that's okay. Now, in this particular section 1 here, as time is passing, we have an upward slope. So here we start off at what speed? And here we end up at what? 20. So what happened to the velocity, between 0 and 15 seconds? Did it increase, decrease, or stay the same? It increased. What do we call that? What is that term that refers to an increase in speed over time? Acceleration, all right? Now, for section 2, we'll notice that the velocity started off at 20 and then stayed at 20 over the 10-second interval. If it started off at 20 and ended at 20, did it stay the same or increase or decrease? It stayed the same. So was there an acceleration? No, but technically you could say acceleration was 0. All right? Sorry. One quick second. Okay. Right. Now, from here to here, which is stage 3, there's an upward slope. Velocity started off at 20 and ended at, so that's between 40 and 50, that's 45, right? So velocity increased over time. So what is that again? That's also acceleration. Stage 4 is also a flat horizontal piece, which means there's no change in velocity over time. So it's a constant speed. So when you have 0 acceleration, it's a constant speed. The particle is still the car is still in motion. It's just not increasing or decreasing the velocity. But here, from time 50 to the end, time 70, we start off at 45 meters per second and end up at 0, right? Which means we slowed all the way down. And what is the other word for slowing down? Deceleration, right? So it's also It's also called retardation. All right. Yes, of course, the obligatory snickles. Right. Okay. Cool. So with that now, what I'd like you to do, please, is I'd like you to answer the questions shown below. Let me see. Is it all fitting? Okay. Cool. Right. So during stage 4, the car is traveling at that with an acceleration of something, and then determine the maximum acceleration. So we had two sets of, now acceleration is the rate of change of velocity over time. So acceleration is the change in velocity over the change in time, which is the gradient, right? It's the change in velocity, which is the vertical component, divided by the change in time, the horizontal component. So you could find both acceleration values, or you could look at the graph and see which one is the big. How will we know which one is the bigger acceleration? Yes, the gradient of the line, the slope. Which one has a steeper slope there? By eyeballing it. I know she didn't say it, but she said something, so I said, I know, no. Yep, that's correct. Because think about it, right? What was the vertical change here? From 0 to 20. And what was the horizontal? That's 15, right? What was the vertical change here? That's from 20 to 45, which is 25 over a space of what time? 10 seconds. So it's either increased 20 over 15 seconds or 25 over 10. So which one was the bigger one? Stage 3. But if you're not sure, you'd find the gradient of both segments. All right, so I'll let you do that in a couple of minutes. Then we'll correct and move on to the next page. Sorry.
Whenever your line is horizontal to your x-axis, the acceleration is equal to 0. Right. No, that's the maximum acceleration. Okay, cool. What was your next page? To find the distance, you find the area underneath the line. So they said for the first 25 seconds. So that puts down here. And this shape right here is a trapezium. So you're just gonna one half of your two the length of your two parallel lines by height. You find this trapezium. This is the trapezium that you have to find because area is whatever. Okay, cool. 1/2 multiplied by the sum of your two parallel lines. So top and bottom by your height. Yeah, good job. Good luck. Okay. And also, yeah. So whenever you're on a graph, whenever your line is parallel to your x-axis, your acceleration is equal to 0. When you're finding your area, your distance, what acceleration. So they want you to find the first 25 seconds. Finding your distance is to find the area underneath the line. So your area under here is a trapezium. So your formula is finding your area is trapezium is 1/2 multiplied by the sum of your two parallel lines. So multiplied by this. So that's gonna find your distance. Now we're on your distance. That's what we want me to like. Yeah. Okay. So when you're finding your distance, or graph or any kind of graph like PCR, like you have this in your formula sheets, is 1/2 multiplied by the sum of your two parallel lines multiplied by height. That's your formula for trapezium. This forms the trapezium right here. When you're trying to find your distance and you want to find what's your area underneath. Your line forms the trapezium. So what we're doing is we're finding the area of your trapezium right here. We have your formula. 1/2 multiplied by the sum of parallel lines
Well, what is correct?
multiplied by your height.
It's 25, right?
So,
that'll be here,
Your
right?
two parallel
So yeah,
lines
parallel.
is this one up here and this one right here.
25.
Your height is how tall it is. You can see it. So we have our first parallel line, which we call this one.
So half an
So
hour.
this is
And then multiply by
20
the
to 25. So that's 10 seconds. So we have 1/2 multiplied by your first parallel line. 10 seconds. Plus your second parallel line. Your 25 will be 25. So it'll be plus 25 multiplied by our height of the trapezium. So if we look up at our height, that's 20. So once you expand and simplify this, that's your distance. Is that okay? Okay. Which other your distance? So this is your velocity. So you're gonna take. So yeah, what you're gonna do is you're taking this point as one of your points, and this point is your second point. So one point will be your x1, y1, other point will be your x2, y2, and substitute that as your. Your max acceleration is your highest acceleration that you're gonna mark. So usually what you would do is you're gonna find the gradient of this line right here. So you would take this point and this point and your line on x1.
Right, so I'll start off with the easy part here, right? So during stage 4, the car is traveling. So stage 4 is here. And if you read across,
Yeah, so we're
Right.
gonna find the gradient of this line.
you get a time between 50 and 40. So that's 45.
This is your second point right here. So you can just write down your, okay, so this would be
With an acceleration. So we already said that during stage 4, it was a perfectly horizontal line. You started off at 45 and you ended at 45 without any increase or decrease in the middle. It was perfectly horizontal. So there's no change in speed or velocity. So it means the acceleration is 0. Right? Right. Right. Now, there are two sections with acceleration. One is here, the green section. And one is here, the blue section. So we have two sets of acceleration to calculate. Now I said maximum. So again, just by looking at it, we could tell that the blue one has a higher rate of acceleration because it's a steeper line, right? The steeper the line is the bigger the gradient, and that's what it is. Acceleration is the velocity, is the gradient of a VT graph. All right, so,
y2 is 20.
sorry.
Y1 is 45.
So, acceleration
When
is the gradient
that'll give you 2.5 meters per second.
of the velocity time graph.
Your A and B is gonna be your two parallel lines. So this
All right.
line
So for the first one in green,
minus 25 or 25
right? So the velocities are
Your second is 25.
0 and 20,
25.
with
Now,
the ending one being V2 and the start being V1. All right. And your time at start is also 0, and you ended at 15. That's your T2. Right. So for the green section, it would be 20 minus 0 over 15 minus 0. That's equal to 20 over 15, which is equal to 4 over 3, which is approximately 1.33 meters per second squared. But we have to calculate the blue because we could see that the blue is a steeper section, right? So we have V1, which is 20 now, because it's starting there, and then V2 is 45. And then time 1 is 25. And then time 2 is 35. Sorry. Sorry. So we have 45 minus 20 over 35 minus 25. That's equal to 25 over 10, which is 5 over 2 if we divide by 5 again, right? And that's going to give us 2.5 meters per second squared. So this one here is the max acceleration. Max ax. All right. Okay, so Google Meet, if you guys are good with that section there, with the acceleration, just kindly give me a quick G in the chat, please, and tax. If you need me to re-explain anything, that's not a problem, let me know. Kai, sorry, I didn't see you there. I'm not watching me the YouTube comments, sorry. I have my class meet open, so I'm not sure what part you're talking about. Kai, if you jump across on TikTok, right, actually have that comment section open, so I'll see that as opposed to the YouTube comments. Sorry about that, Kai. All right, so Aisha, Christian, Donovan, Julie. All right, cool. All right, so Mr. D has to let me know what's going on, right? Okay. All right. All right, my in-class people, were you okay with the section on the board there with the acceleration? All right, so I think most of you will actually work through the next part as well, so I'll do that one time. All right, so for those that are playing the home game, I'm going to talk through this one, right? Just to kind of save some time because we already at 7:30. And we have the next 2 big questions to do. So this might spill over to Wednesday. Anyhow, what is the must is, right? Calculate the distance traveled by the car during the first 25 seconds of the journey. The distance traveled by the car is the area under the graph. Right, area under the VT graph. So let's go back to the graph. Let's take out a lot of the notation that we had so we could, it's not cluttered and confusing when we look at it. Okay, and we're going to zoom in. We're going to zoom in, right? So the first 25 seconds places us here. So we're going to put a line here. And this shape is a trapezium. And the area of a trapezium is 1/2 of the sum of the parallel sides, which are these 2 sides here, multiplied by the perpendicular distance between them. All right, so the horizontal, the first parallel side down there is 25. The second parallel side, so this little section here ran from, there to there. So the whole thing here is 25. This little piece on top here is just 10. And then the perpendicular distance between them is 20. So you have 1/2 of 10 plus 25, then multiplied by 20. Right? So that's, so the distance is equal to 1/2 by 10 plus 25, then multiplied by 20. Right, 10 and 25 is 35. Right, 1/2 of 20 is 10. 35 by 10 is 350. Right. Now, don't forget to put the units, right? Meters, because it was in meters per second and then seconds, right? If they had asked for kilometers, you would have had to convert, all right? Okay. So again, yeah, I didn't mean to rush through that part, but I'm watching the time too. All right, so if they ask you for the distance traveled by a vehicle or whatever, and you have a velocity time graph, right? You have to find the area under the graph, right? So most times it's a trapezium. Sometimes you might get lucky. It might be a triangle. It might be a rectangle. It might be a square. It will probably not be a circle. And if it was the actually total distance traveled, what you would have had to have done is break up this graph into different pieces. So you'd have the first trapezium, then a second trapezium there, and then a rectangle and a triangle. Or you could have done a third trapezium here, right? So it could be 3 trapezia or 2 trapezia, a rectangle, and a triangle. Right? Okay. Okay, so let me print out a couple things for some people in class who may not have it yet. G's on ages. What? Right, I'll put the question. Let me just print out for those. I have a couple of people in class who do have the question paper. So I want to yeah. Well, come now, man, Philip. Be yourself. Oh, no. So therefore... Okay, just give me a couple of seconds. Let me just print out this stuff for those in class. A couple of guys forgot their printouts, so I don't want them to be scrambling. Okay. Okay, so question 9A, part 1. So question 9 has usually circle geometry as well as trigonometry, including bearings. All right. Whoops, sorry. All right, so the diagram below shows a circle with center O. So we have center O, all right, and the points P, Q, L, and N. P, Q, L, and N lie on the circumference of the circle. Ln is equal to NQ. Ln is this line here, is equal to NQ, which is this line here. So as a matter of fact, we could actually see a couple of strokes there. And those strokes indicate that those lines are equal in length. So quick question. If you were to close up your triangle there with the pink lines, what kind of triangle would it be? Isosceles, because 2 of the lengths are equal. And it also implies that these 2 angles here are equal as well. Because not only are 2 lengths in an isosceles triangle equal, the opposite angles to those lengths are equal as well. Right, so again, just observations as you're going into the question. RM is a tangent to the circle. So RM is a straight line here. And a tangent is a line that touches a circle at one point. It doesn't intersect. It doesn't go through the circle. It just touches it at one point. And that gives us 2 rules. The first rule is that the angle between a tangent and a radius is 90 degrees. So you have a 90 on that side and a 90 on that side. And we have a chord on this side. And the angle between tangent and chord is equal to the angle in the alternate segment. Right? I wouldn't put which one that is yet. Because there are 2 different angles it could be. And it means that on this side now, this angle here is also equal to the angle in the alternate segment. That one is actually on the diagram. All right, so come to man, Philip. All right, explain why angle X and angle NQL are equal. Now, I'll tell you something funny. When I first did the paper, the first live I did with it, somehow I read, explain why angle X and angle NQL are not equal. Somehow my brain saw NQL and said not. And you know what happened? It happened just now again too. I don't know how, I don't know why, but it did. So explain why angle X and angle NQL. So NQL starts at N, goes to Q, and ends up at L. So this angle here. So I heard Khalifa say, Khalifa, tell them. Why are they equal? You didn't say it? Beautiful, right? So angles, angles in the same segment standing on the same arc are equal. Very good. You know your thing, right? So angles. So if we, now you could blank out a couple of lines to see things a little more. So if you blank out this line here, you can see it's the kind of Spider-Man thing or the kind of double triangle thing, however you want to call it, right? But how, to get a segment, to me, the arc, the chord will help define the segment, right? So angles in the same segment. Right, standing on the same arc are equal. Now there are different articulations of this rule, right? Some people say angles subtended by a chord are equal, or angles in the same segment are equal. Standing on the same. All right, cool. Right. Hey, Saif, how you doing? Thanks for sharing. And Anjanea, and the Beauty Genie, and Ray Bagley. Not sure. All right. Okay, so this angle here is also equal to angle X. All right. Now, that's the only question on this page with respect to this question here. Right? So angles in the same segment, standing on the same arc are equal. I see. Hey, I see. How you doing? Evening. What vibes? What be there vibing? All right. Sorry, that's one thing. Tap to set up your pro. I don't know what it is. Wait, I didn't send some other solutions in the chat. I did forget. All right, cool. Hold on, I'm gonna send this one. All right, so that's a rule you have to know. If you don't know your rule, you might want to go over the notes or the replay. Right, that would be a very early replay in circle geometry from about mid-October. Right. Now the questions are as follows. They wanted to give reasons for angle X and angle Y. So we're going to go back to the diagram. So they wanted to find the value of angle X and the value of angle Y. So what I'm going to do is I'm going to give you all, I'm going to give you all a couple of minutes to see if you can figure it out. Now again, you're not under exam conditions, you can ask for help, but try, okay? All right. In case anybody needs a little help to see that first reason, right? So this line here is a chord. All right. If we build, right, a triangle on that chord like this, all right, and then we build another triangle on the same chord. Right, so basically you have two triangles. Both of them have the green base in common, and they both touch the circumference of the same circle at different points in the circumference. So if you have triangles built like this in a circle, the angles at the circumference are equal. Right, the angles opposite the common chord. Right. If we were to draw another, let's do another one. Right. If we draw another triangle, right, guess what would happen? This angle here would be equal to X, right? And there you go again. All right, if you were to draw another triangle, this angle here would also be equal to X, right? So all of those triangles are built off of the same green line, right? And they just touch different points on the circumference coming down. All right, we could even draw a next one. Right, it could be from there, from the same stuff. So once they start from N, they hit that circumference, and then they go down to L. That angle is also X. So all of those angles there are all X. All right. Sorry. All right. So that's again another way I could show. Right. And you could fit other ones in between if you want, right? You could show. All right, that angle there is also x. And you can fit it anywhere along the circumference. So once you start at N, you touch anywhere on this circumference here, and you end at L. Thereafter, the angle at the circumference opposite the green line would be equal all the way down. All right, so Google Meet, if that helps, just give me a quick Genie chat, please and thanks, right? So Google Meet abandoned. Oh, okay, thanks, one man. Alright, so yeah, so again, if you build triangles, so in a circle, if you draw a chord, the green line, and you keep building triangles on that chord, such that all of the apexes, apices, touch the opposite circumference, then those angles at the circumference are all equal. Cool. All right, so they ask for x and y. All right, so I'll give you angle x. Right. Oops. Yeah, this is 63, that's correct. Sorry. And the reason is because, so this 63 degrees here between the tangent, between the tangent and the green chord, that's equal to the angle in the alternate segment. Now, what do I mean by the angle in the alternate segment? So this is where blanking out some lines to come in handy, right? So if I blank out this white line here, right? So if I build this triangle, this blue triangle there, right? That angle x is what we call in the alternate segment. It's on the opposite side of the green line, right? Which puts it in the alternate segment, right? So a segment, by the way, is an area of the circle between a chord and the circumference, right? So you have, so this piece down here is what we call the minor segment. So when you hear the word minor, what do you think? Big or small? Smaller, right? Because, and that's the minor, because the rest of the circle is the major segment, right? So this yellow section down here, well, what was yellow, right? That would be the minor segment. And then the previously unshaded part would be the major segment, the alternate segment, all right? So this angle here would be equal to the 63, right? So x would be equal to 63 degrees because angle between tangent and chord is equal to angle in alternate segment. Well, there's 3 cams. I just had 3 cameras. I wanted to use them all. That's about it. But they're not blocking anything, so you should be okay. All right, okay. And as we said, this angle across here is also equal to x. So that's also 63 degrees. Okay, so the other angle they wanted to find is y. Now we're going to give you a little more time to find y if you have not yet found it. Yep, I agree. Sorry. Okay, no problems.
Right, sorry. It's Kilo. Hey, Kilo, how you doing? Question mark. Question mark is about what the y, the green angle? Don't worry, we do not know. Right. So those two green sides are equal, right? Which makes the, well, okay, I guess I'll put that one in orange, right? Right, which makes the green and orange triangle an isosceles. All right. And what else do we know about an isosceles? Not only are the, are the, what you call it, the lengths equal, but the opposite angles are also equal. So those two angles are x, and we just saw that x is equal to 63 degrees. So if we know that those two are 63, how do we find y? That's correct. So y would be equal to 180 degrees minus 63 by 2. Now you could do 63 by 2 or 63 plus 63, it matters not. So that's 126. 126 from 180 will give us 54 degrees. Right? And you could attribute it to two rules, two things, right? So angles in a triangle sum to 180. Sum will add up to 180. And base angles of an isosceles triangle are equal. Sorry. All right. Add them and minus. That's correct. Good job, Kayla. Chaos incarnate, boy. What? Oh, it's 54 divided by 2. All right. Good job. Good job. All right. Okay. Google Meet. All right. So those who are left. So I have Aisha Donovan, Christian, and Jaquan. If you guys are good with that, those two reasons there, pink and the green, give me a quick G in the chat. If you need me to re-explain, let me know. Sorry. Chaos and Connor, thanks very much. Should you follow? Am I? How are you doing? All right. And in class, people, were you okay with the solution on the screen? Any questions? Anybody? Anything? Wait. All right. Well, I'm gonna zoom out a little bit, and I will send a picture in the chart. Chart. Right. So I'll leave it up a couple seconds again, but I want to go on to the Triggs questions. All right. Oh, thanks for the 1,200 likes, boy. That's crazy. Wow. Thanks very much, guys. I appreciate it. Okay, cool. All right, I'm gonna switch up now, all right, guys? Sorry. GF. Okay. All right, guys, we are on, what is this? Question 9, part B. Let's take a quick read and let's let you guys try the question, right?
Okay, let me zoom in a little bit more. I'll zoom out just now. So, two ports E and G are on level ground 245 kilometers apart. So, E and G, 245 kilometers. And we see a north line. So, bearings is probably going to rear its head in this question. The bearing of E from G is 302 degrees. Now, E from G means it's starting where? Which port? E or G? You're starting from G. And the bearing is the clockwise angle from the north line between that line and the line connecting the two ports in this case. Right? So that arc there, that's 302 degrees. Now, what's the sum of all the angles at that point? 360. So if we wanted, we could find the remaining angle here by doing what? 360 minus 302. Right? We could do that. Now, it goes on to say a ship is anchored at F. Sorry. Okay, hold on. I'll zoom out a bit. Right. Yeah, okay. So a ship is anchored at F, which is some distance away from G on a bearing of 228. So there's a different bearing from G. Hold on. So the green bearing, the green angle is 228 degrees. Okay, cool. And angle EFG is 52 degrees. Okay, cool. This information is shown in the diagram below. Okay. So on the diagram above, insert the angle 228. All right, so we inserted both, right? And they wanted to determine the value of the angle FEG. FEG starts at F, goes to E, and then goes back to G. So it's that angle there. So this angle here. Oops. Sorry. Sorry. So what's the easiest way to find that angle, ladies and gents? Not add. If the pink angle is 302, sorry, let me get that back. Correct. So if this is 302 degrees and the green one is 228, sorry, no, you said the correct thing first. Sorry, my bad. I misunderstood what you were answering the actual question that I asked, how to find the blue, right? But I was asking how to find this piece inside of here. Because then you have to add that to the 52 and then subtract it from. So no, you're correct. Sorry, Liam. Right. Correct. So 302 minus 228 is 74, you said, right? Right. So this angle here is 74 degrees. Sorry, 1 second. So how do we now find the blue angle? 74 plus the 52 from 180, right? All right, so 74 and 52 is 126. Do we get 54? Did we get 54 just on the previous question? Okay. That's interesting. Chaos saying 58. 58 for the angle. Hold on, Chaos, I know what you found. Chaos found this angle here, right? 58 degrees. Yeah, I could agree with that. All right, cool. All right. Google Meet, just give me a quick G in the chat if you're good with how we found the blue angle, please and thanks. All right, there was a step-by-step approach. All right, cool. That's one man. Two. All right, cool. All right, my far side. Zian and Diane, we okay what we have so far there? Sure? All right, cool. All right, just Noah and Jadon. Talk to me. We okay with that? All right, cool. But they go central ladies, you're okay with that first piece there? Okay, because it do get easier after this, eh? All right. Okay. So, the next part of the question is asking, calculate GF, the distance, the distance the ship is from port G. Sorry. So they want GF. Hold on, it was 54 we got? Okay, so check it, right? They want you to find the blue distance. Now, in a lot of the questions with bearings, we used cosine rule, but to have cosine rule to use here, we need to have this length here. Do we have that length? No, we don't. Do we have any length in the triangle? We only have one. Do we have the angle to which it is opposite? Good. Now, the length that we want, do we have the angle to which it is opposite? Yes. Right. So, if we can't use cosine rule, the other rule available is sine rule, and we have the information needed for it. We have pairs of angles and sides opposite each other. So, I wanted to use the sine rule to find the blue length for me, please and thanks. Sorry. It's common A over sine A is equal to common B over sine B. That's correct. But here you have E and F and things. So use the appropriate letters. Sorry. Yo.
Sine rule is length over angle, right?
Yeah.
Yeah, length over angle. I don't know how to tell their corresponding angles. And then you cross multiple equal lines. You know how to tell which length goes with which angle.
All right. Daniel Darko. Hey Daniel, how you doing? Daniel, so not Daniel. Yeah, yeah guys. So, YouTube people,
We'll call her length.
I do get to watch the comments here as we over on TikTok mainly. As a backup stream for this, interesting enough. But as we watching my Google Meet comments, that's what my class is. Right? But if you want to see your comments, just check me on TikTok. Same handle adaptation. Yo. I will let you know shortly. That sounds correct.
I'm gonna just cross multiply. See, I already went it off. So that'll be sine 52 by x is equal to 245 sine 54. And then last thing I'm gonna do is I'm gonna divide both sides by sine 52. So my length is
Right, sorry. Page. La.
by sign
We have to do all this in variance. Yep. Yes, hello page.
over sign.
Boop, boop, boop. Sorry, I'm now seeing it.
Calculator, that should give you a
Alright. My head hurting with this? No, don't worry. Variance is max 4 marks on the people, bet you. It could be 5, depending on the question. But that's highly unlikely. All went well? Alright, we'll go and get some sleep. No? No? What happened?
I have presentations tomorrow. I can't.
Okay.
And I have a PhD meeting Wednesday, so I actually was supposed to finish. So I actually send that tomorrow. What's up?
Right.
For them to review. That was good.
Wow. Okay, cool.
Okay.
Alright, later. Alright guys, I'm gonna open the screen now. So let me
If you're using like decimal points, something like that.
right.
So for the
Quadratics.
you wanna look at first and
So yes and no. So when we do the question twos, we do like quadratics and factors in it. But if you need this, if you need like a kind of crash course on it, let me know. I actually have some stuff available I could send. But yeah, I like email and things, so I could get your email address.
So we're gonna go.
Okay. Right. So just like Mishka's been telling you all, the use sign rule, what we need is we need lengths and angles that are opposite to each other. So yeah.
So you can show
It's
all
hard.
your reading.
Yeah, it's I completely forgot how to do that.
Okay, that's not that.
I'm feeling so much shame I can't remember how to do that anymore. So I always used to do that in like chemistry and stuff.
Hold on. It's supposed to just be that button down there.
Wait, let me try something.
Yeah.
Okay.
Right. Hold on. Right. So we need
Okay. That's up. Then I'm gonna try 0. And 0 here. And put it
so this is side E across here, this is side F. So so we have E over sine E is equal to F over sine F. So the convention is that the lengths have the common letters and the angles have the capitals. POA crash course? Yeah, April. Coming in April. Email me to book a spot. No, you don't have to pay to book a spot. I just need the name because people have been booking spots already since January. Right. Okay. So E. So we have E over sine 54. And that's equal to F is 245, right? So 245 over sine 52. Right. Now these values are going to be very close. And the reason I'm saying that is because look at the values of the angles. What are the two angles we're working with? 54 and 52. Those are pretty close together. If you take one from 54 and give it a 52, they'll both be 53, right? So they're pretty close. So we could kind of guess that this value is going to be in the vicinity of 245, right? So to solve for E, you have to remove the denominator. How is the denominator attached to the numerator? Division. How do we remove something attached by division? With multiplication. So we're going to multiply throughout the equation by that denominator of sine 54. Sorry. I said sine 54 and wrote that in the wrong place. And I wrote 52 in the wrong place as well. Look at that. So always pay attention to what you're doing and double check your work. Right, okay, so it's just a plug and play now. 245 divided by sine of 52. Then multiplied by the sine of 54. So 251.5, so approximately 252. So 252 kilometers to the nearest kilometer. Yeah, question. You should? If it, 251.5?
Just put the one decimal place. Right? Now, that being said, I have realized that there's a standing rule on the front of the paper, and I'll show it to you, right? The standing rule says numerical answers that are non-exact should be given correct with 3 significant figures. So the first 3 digits, the first 3 non-zeros, technically, right, will be 251. But then if you go to the right of the 1, it's a 0.5, which will round the 1 up to 2, right? Now, you wouldn't get it wrong, right? It's just that you wouldn't get them the accuracy they asked for. I don't see that being a big penalty, right? Once you do like 251.5, blah, 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 unnecessarily. All right. Oh, thanks, Jaden. Thanks, Nelly and Anya. Okay. In class, people, are we okay with the green, the sign rule? Any questions, anybody, anything? All right, Google Meet, if you guys are good with that, just kindly give me a G in the chat. Please and Fong. Shania, still the send your stuff for me. Shania, you gotta remind me what I promised to send for you. The weekends is be real hectic and I forget anything I promised anybody. I'm real sorry. Your best bet is to DM me on Instagram or TikTok or email me, and that way I'll see it every time I open my inbox. Right? And if I forget, then message me. You can message me like every day. Just don't overdo it, right? Alright, so I share Donovan, right? So take one and we could probably finish question 9 and start question 10. Alright, the last piece here. Indicate the point H on the line EF such that GH is the shortest distance from G to EF and determine the distance GH. Right, that's plenty. That's a mouthful. So what we're going to do, we're going to copy over the diagram fresh. All right, we're going to take off plenty of these things. Let's zoom in. All right, and what we're going to do is we're going to reread what they asked us for. Okay, indicate the point H on the line EF. So first of all, EF is this line here. So there's a point somewhere on EF, H, right? Such that GH is the shortest distance from G to EF. Right. So that distance is a straight line. But watch me on this. If I drew from G, if I drew a line to here, to EF, does that look like the shortest possible line from G to EF? There go Central ladies on the screen here. Right. Is this the shortest possible line from G to EF? Or what if I went here? Does it not look shorter? Or what again? Until I hit right there. And guess what the angle is between that line and the black line? 90 degrees. Right? So this what they threw in here was a piece of geometry. Right? They wanted to see if you knew what the shortest distance between G and the opposite side was. Right? That vertex G. And it's given by the perpendicular line. Right? Now, it's not the perpendicular bisector because we don't have that. Right? At least not from point G. Right? And the opposite side is 90 as well. Now, what do they want? They want that distance GH. Sorry, hold on. Now, how are we going to get GH? Well, hold on. Didn't we just find the blue length? Well, it was 252, right? So check this. Let's take out some of these extra things as well, right? Okay, so that's kilometers. So check this. What kind of triangle we have with that blue line there? A right angle triangle. With the blue line as what length? What special length? Right, so we have a 90 degree angle here, but the name of this line would be the hypotenuse.
And the line we want is opposite to the angle that we have, the non-right angle. So what are your three ratios that we use in non-right angle, in right angle triangles? We have sine, and sine is equal to the ratio of the opposite length over the hypotenuse. The cosine is the ratio of the adjacent length over the hypotenuse. And the tangent, I think this is the one you wanted to say, is the ratio of the opposite length to the adjacent. Right. But we're looking for opposite and we have hypotenuse. So which of these three are we going to use? We're going to use sine. All right. So how we'll set it up is that, is that sine 52 degrees is equal to opposite, which is GH, over 252. So to solve for GH, all we have to do is what? Remove the denominator, which means we have to multiply. Very good. So we have sine 52 multiplied by 252, and that'll give us the value of GH. All right, so that's calculator food. So 198.57, so when you round it off, 199. 199 kilometers, so almost 200 kilometers. That's the shortest distance between G and that the line opposite. I feel like I forgot to send some pics as time went on, so we have some gaps. Sorry. Which one is that? Vectors? All right, Julia, I wanted to send me a message now on WhatsApp. Just say vectors. Vector, you can put vectors videos, right? All right, cool. You need vectors too? All right. Now, it will be the recordings from about late September to mid-October. It'll be about 6 or 7 of them. All right, so just take your time and go through. Okay, Google Meet. Just give me a quick Genie chat if you're good with what I just did there with the right angle triangle, please and thanks. If you're not sure, you need to re-explain, give me an R. Okay, thank you. All right, guys, so we are going to run out of time, so I doubt I could finish the whole paper, but we can at least start question 10. That's vectors. All right, so here we'll do the matrices question first, and we'll round back and do vectors on Wednesday. Now, also on Wednesday, we'll probably start another paper because we've basically done this one. So, hey Ken, good night, how you doing? So what y'all feeling? Y'all feeling for May 2024 or Jan 2024? Stay with the Jans or go backwards in sequence? What y'all feeling? All right. All right, cool. Yeah, so one for Jazeera, one for Noah. All right. All right, so I can give you about a 5 to 7 minute head start on the questions. There it says determine the values of each of the unknowns in each of the matrix equations below. Right? So this was the entirety of the question. All right, so like I said, 5 to 7 minutes, and then I had to start so I could finish here on time because you know the car situation outside has been a little sticky. All right, and I didn't see Nyla, and yeah, I know it was raining a bit earlier. Uh-huh.
Yeah, so like this one, this matrix is attached to this
Why are
one,
we
right?
getting?
By multiplication, so then
Hold on.
so we have A, B, C, and D. You're gonna find the determinant, which is 1 over A, B minus B, C, multiplied by, you'll switch these two, and you'll change the signs. Multiply this together.
Gigi's Catering, how you doing? Good to see you on tonight. Oh. All right, Jade, sorry. Jade Dunn. So angle EGF is in 14 degrees. EGF. EGF. As in this whole piece here? Nah. That's 74, not 14, sorry. 74. Okay, we'll come back to that. Sorry, this delay will stay up for a little while, so they could always check back on it. And if anybody know who Kai is, tell Kai RL sorry. I didn't see the R. Can you re-explain? Yeah, this will be on the YouTube chat, sorry. I'll find a way to fix that. Actually, I know exactly how to fix it. I think I do. I know. Okay. Alright. I'll start with part B, part 1. Alright, so when we're adding matrices, we just add corresponding elements. So 4 plus x should give us minus 3. Alright. Alright, 0 and the 2 would give us 2. Actually, we don't have to consider all of that because that one kind of obvious. It's just the x and the y. Okay, so don't even worry about that. So 4 plus x is equal to minus 3. But to solve for x, you have to get rid of the 4. The 4 is being added. So to get rid of it, you have to subtract it from both sides. So x would be equal to minus 7. For the y, so minus 2 plus 8 would be equal to y. Minus 2 plus 8 is equal to y. Minus 2 plus 8, same as 8 minus 2, so that's just 6. All right, so did we get minus 7 for x and 6 for y? All right, cool. Okay, lovely. All right, so again, I'll give you a few minutes again to sort out part 2. Part 2 is 4 marks, so you might have a couple things to do there. Sorry. You have to set up some simultaneous equations. Hey, Bianca, how you doing? So, if I find the inverse of the first one, I could multiply it. Actually, that might be the better way to do it, you know.
Okay. Because that's what I was saying.
If you find the inverse, right? Okay, then you do it like that, and then when you multiply, yeah, okay, let's try that. That's a more matrix-centric approach. So that might be the better one to do. Yeah. Okay.
So yeah, it's cool to find the inverse of the first matrix.
Yeah.
Okay.
All right, cool.
The first thing I'm gonna do is I'm gonna find my inverse.
All right, so we're gonna invert this matrix.
Our formula for finding our matrix
Let's call it A.
is one over your determinant.
Yeah. So A inverse is equal to 1 over the determinant of A multiplied by A adjoint. So you're going to multiply these two together. And then you're going to minus 3 by 2.
So we're gonna move this one across. So our A matrix is equal to
And then for that same matrix, you're gonna swap out the 5 and the 3. And then change the signs of the minus 22.
well, it's okay.
It's 21. Yeah, okay, cool. So you have 1 over 21 by 3, 3, 2, 5. Now, if you multiply this by A, right? I'm going to put that in some notes. Right? Now, if anyone needs a crash course on matrices, I actually have videos up on YouTube with that. So if we did A inverse multiplied by A, we'd actually get I, which is the identity matrix. And if you multiply I by, let's call this matrix B. So if we did I multiplied by B, you get back B. But of course, whatever you do to one side, you have to do the next side. So if we call this matrix C, right, we have to do A inverse by C. Right, now you don't have to put this 21 inside, yeah? Not yet. That's 15, that's minus 6. 15 minus 6 is 15 plus, that's 21, right? 3, 3 minus 2, 5. Okay, cool. Right, so to multiply matrices, you have to multiply row by column. 3 by minus 10 is minus 30. 3 by 17 is 51. Gotta add that. And 3 by 13 and 3 by 1. That's 39 plus 3. Now bottom row by first column. 2 by minus 10 is minus 20. And 5 by 17 is 85. And then second row and second column. 2 by 13 is 26. And 5 by 1 is just 5, right? (26) and 5. How to find determinant? Right, so determinant is you have to multiply the diagonals, the elements on the diagonals. So 5 by 3 is 15. Right? Minus 3 by 2 is minus 6. But you're subtracting that from the 15. So it's a 15 minus minus 6. Minus 10, 13, 17, and 1. 2 by 13 is 26. 5 by 1 is 5. Okay. Now we're really only interested in A and C, right? So we really only have to find for this and for this. But we're supposed to get back the same thing. Hold on, huh? Something not adding up here. We have 1 over 20. Mishka, if it, you could just eyeball my work in there and see if minus 30 plus 51 is minus 21. 39 and that is 42.
So that would count for A, because I'll give you back minus 1.
Right. And then minus 20 plus 85. That's 65, right? And then 26 and 5 is 31. But then that wouldn't tie back to this. Sorry, to this. Right? If it is like 1 over 21 by 42, we get back 2. I'm okay with that. 1 over 21 by minus 21, I could get a minus 1. That's fine. I feel they wanted this to be, well, not that. Because that'll give you 3 and 1/7. Sorry, 3 and 2 over 21. Yeah, so these values not tying back. Because I was saying that this might be wrong, but when I check the thing, so we okay with the inverse, right? 1 over 21 by 3325?
This is supposed to be minus 26.
Which one?
This one, minus 26 plus 5.
Down here?
Yeah. And then,
Yeah, because this is a minus 2.
yeah, I'm seeing that, yeah.
Wow, okay. So that's a 20 there.
Yeah, that'll give me back your minus 1.
Right, so you see, it's a simple sign. See, I ready to blame the question, it's my fault, eh? Look at that, wow.
Yeah, so now looking like that.
Yeah, so we good. So that's 105, and then that's minus 21. Right, so when you divide each of these by 21, you're going to get minus 1, 2, 5, and minus 1. So A and C correspond to it. So A is minus 1 and C is 5. Wow. Okay. There you go. Sorry about that. That's my bad. All right, so folks, we're not done with this paper. Eh? We still have the vectors question to do. All right. When we come back on Wednesday, we're going to round off vectors, and I'm going to print out the May 2024. So come prepped. All right, Google Meet. That's about it for this evening, right? So if you have any questions, please feel free to WhatsApp me. But yeah, I had a cut and run there because I had to let these kids out.
Can you unplug my charger, please?
Yeah, no problem.
Is it okay if I can get paid for it?
Yeah, I have more. That's no problem. Yeah.
Perfect. Thank you, Chris.
Yeah. Shana, you said me. I'm not sure what you mean, but like a May exam? Or you doing the exam in May? Okay. Alright, yeah, I go on there, YouTube.